Well, it is not day 12, it is day 6. It is Wednesday, June the 4th, and yesterday we took that Unit 1 quiz. And I just gave you guys some time to work on corrections or to get started on the practice quiz if you were not here yesterday. And then I gave you a little sneak peek of what we're about to start talking about, which is triangles. So in the last unit, Unit 1, we did lines, rays, angles, mostly things that are looking like straight lines there. And now we add a third line and we get a triangle. So the first thing we're going to do is I'm going to give you a bit of a demonstration. And for the sake of time, I'm just going to show you the demonstration. This is not something that you have to do, but here's an example of a triangle. Let me grab a pair of scissors so you can see what happens here. Notice that I have A, B, and C, 3 angles named in a triangle. And a triangle will always have 3 sides and 3 angles. The first thing we'll learn about a triangle is what these 3 angles always add up to, no matter what shape and size the angles are in the triangle. So I'm going to take this triangle and I'm going to cut it out. I'm going to show you something kind of neat. So cut out one side, 2 sides, and my third side here. Cutting skills are not exceptional. And now we see our triangle shape. And then I'm just going to chop up the triangle a little bit further and separate my 3 angles. So here's an angle, angle A. Here is a second angle, there's angle B. And I have a third angle here, angle C. Anytime I take a triangle of any size angles, if I put the 3 angles together, watch what happens. So here's one angle. Here is my second angle. Just going to line that up, make sure that the points of the vertex go together. Good reminder, let's silence our phones. And then the third angle. If you are looking at this, as we all should be, about what measure do you think?
180 degrees. I'm so sorry.
Yes.
I've never seen this done. This is
Isn't that cool? This is the way I was taught about triangles in college, and it was the only thing that made sense to me. Every triangle, no matter how skinny the other 2 angles are or how big one of them is, they will always form a 180-degree angle. So now that you've seen it, anytime we have a triangle, we know the 3 angles add up to 180 degrees. Isn't that cool? I know, it is cool. So with that demonstration, we're going to take some notes and get that idea on a piece of paper. So I'm going to title my notes a big Unit 2 because we are in a new unit now. So geometry. This is Unit 2. Unit 2, we are just going to be talking all about triangles. And triangles is, I think, a pretty cool name to give it because it's very self-explanatory. That prefix, the first part of the word, tri, T-R-I, does anybody know what that means? It means 3. Tri means 3. And the other half of the word is angles. So a triangle is a shape that has 3 angles every single time. So a triangle has 3 angles. So just a little something. Keep in mind, we name things the way that we name them for particular reasons, especially in math. Triangles have 3 angles. So I also want to write what day it is. It's day 6.
Yeah, on your other paper, you had November.
Didn't I? That's from the last time I taught geometry.
Oh.
So day 6, and it is Wednesday, June the 4th. Is that right?
Yeah.
Okay, perfect. Okay. So if you didn't get a chance to write down what I had on that little paper I was displaying, we're going to write it again kind of as a class and explain what everything means as we go. So in a triangle, start by just drawing a triangle. It doesn't have to be perfect. I am going to start with something like this. So everybody draw yourself a triangle. If you want it to look really nice and pretty, you could use a ruler. I just made my triangle. Each side is a little over an inch, about an inch and a quarter. If you're trying to make it copy fine. And in a triangle, the first thing that we like to learn about is what we call interior angles. Interior angles are those angles inside the triangle. So I'm going to mark the arc. We'll call that angle A. Call this angle B. Call the third one angle C. So this is what we call our interior angles. Just angles in the triangle. And what we learned through that little demonstration when we cut the angles off the triangle and put them together is that no matter what, your interior angles, all 3 of them, add up to 180 degrees. They make that straight line. So I'm going to write below interior angles A, B, C, and I'm going to put a plus sign in between them. A plus B plus C equals 180. And this is sort of the formula we're going to follow for nearly every problem. Now, sometimes we like to take it a little step further. There may be, this angle, this triangle might be on a few lines. It might be on something like this. Maybe they'll stick a little line right there. I don't know, maybe they'll put one here or here. Sometimes the triangle can be formed by mini lines like this. Okay. The idea here is that if there are any angles not inside the triangle, like this one here, I'll mark a few. Here's an angle. Okay, notice how I use a different number of arcs. Why did I do that?
It's wider.
It's wider, it's a bigger angle. These are not the same measure. So I drew a different number of arcs to show that there could be an angle here, wouldn't be the same. This could be an angle. There's so many angles we could create on a triangle. But these angles that are outside of the triangle are called exterior angles. Exterior. And there's no real perfect formula for the sum of exterior angles that I am currently aware of, other than I know that if I take an exterior angle that is right next to or adjacent to an interior angle, when I add them together, what will I get? 180 degrees. And that's because angle C, for example, and on my paper, I call this D, call that E. Angle C and angle E form a straight line. So we could write another little formula here if we wanted to. For example, C plus E equals 180. Are there any other angles that we noticed we could add up to get 180? Yes, Erica.
Both on the corners.
Say it again.
The angles on the corners of the triangle.
The angles on the corners of the triangle. Oh, like the exterior corners right here? Ah, okay. So this would be like that. These are vertical to that interior angle. If I call this, I don't know, let's call this F. What is F equal to? C. Yes, these are vertical angles. They're angles right across from each other, so they're always equal. Yes.
You take the angles such as F there, and you turn those into triangles, and you do that a couple of times. You'll be
Ooh, that's an interesting thought. Like if I were to continue the lines and
yeah,
that's cool. Yeah, there's a lot of really cool things we can do in geometry. I wish we had time to talk about them all because I don't know. Geometry has always been my favorite because I am a very visual person, and whenever I can kind of see it happening in front of me, I don't know. I might just be a nerd, but I think it's cool. So we're gonna stick with this for now. Just know that with triangles, the magic number is 180. We're almost always gonna be setting this equal to 180, which is helpful. Now we're not kind of doing as much of a guessing game. It's almost always gonna be 180. Now, this triangle that I showed you has 3 angles that are all the same. There's a special name for it. We'll get into that here in a little bit. Do you know the name? What is it? Equilateral. Oh my goodness. This is called an equilateral triangle. Don't worry about writing it down yet. We'll get there. For now, I want to talk about the different types of triangles when we refer only to angle types. So let's see. Let me get a different color here. And I'm gonna write types of in unit 1, we talked about a few types of angles. Talked about acute angles, right angles, obtuse angles, and straight angles. And with triangles, we can have 3 of the 4 kinds. There's one kind that doesn't exist. We're going to start with acute triangle. An acute triangle has 3 acute angles. Every angle is less than 90 degrees. So let's write that. Say all 3 angles are acute. Less than 90 degrees. So with an acute triangle, all 3 of the angles have to be less than 90 degrees. If even one angle is 90 degrees, now we have a different kind of triangle. So for my acute triangle, I'm going to draw a little picture. See, it can be super similar to the one up there. We just want to make sure that none of our angles are 90 degrees or more. So I'm going to draw a line there. Here. Notice how every single angle is less than 90 degrees. Now, these angles are probably not all equal to each other. In fact, I can tell you they're definitely not all equal to each other. But just for the sake of the drawing, I'm going to do it like that. A triangle we'll talk about, say, right triangle. Now, whenever we talk about a right triangle, your first thought might be, well, maybe it's a triangle with all 3 angles right angles. Would that be possible? Yeah. It's not going to be possible. You will have 2 shorter sides. You're going to have a longer side. With a right angle, that's 90 degrees. If I have 2 right angles, how many degrees is that? 80. That's already 180. If you have more than 180 degrees, you don't have a triangle anymore. Doesn't exist. It won't work. So a right triangle is a triangle where there's just one 90-degree angle. You can only have one. So I'm going to write one 90-degree angle. Just one. You can't have more than one or it's not a triangle anymore. And whenever we draw a right triangle, we start with the right angle. So like line somewhat straight up and down, and then a line straight left to right. And we always want to put that box there. And we just connect the points to create the third line, third side of the triangle. So the right triangle has one 90-degree angle. And what kind of angles would the other 2 be? Acute. If they were obtuse, that would mean they're bigger than 90 degrees. Which would mean that we have more than 180 degrees. It wouldn't be a triangle anymore. That's all right. Okay, so you have acute triangle, we have a right triangle, and last but not least, we have different color again. We have obtuse. Triangle just has one obtuse angle. So one angle, which is an angle that is bigger than 90 degrees. A triangle have more than one obtuse angle? No, no, it cannot. Does anybody know why?
Bigger than 90 degrees.
That's bigger than 90 degrees. If I have two angles bigger than 90 degrees, I have more than 180 degrees. I am past the limits of a triangle. So whenever we draw an obtuse triangle, I usually like to start with a line kind of tilted out so I know I can start with a bigger angle. Like that. And I'll create the obtuse angle with my second line. This is the obtuse angle right here. Then I connect the dots, or not the dots, but the ends of the lines to create an obtuse angle. And there's one obtuse angle, and the other two have to be acute. And seeing it visually is helpful. So I'm going to show you, starting with the right angle, why you can only have one right angle. If I were to start with one right angle, okay, so I have two sides, and a triangle has three sides. If I made my next angle a right angle again, yeah, I can only have three sides and three angles with the triangle. There is no way I can make this third side connect to the first side with two 90-degree angles. This will never be a triangle, ever, no matter how hard you try. I mean, you can try to connect it with a curved line, but now that's not a triangle. So that doesn't work. And it really doesn't work with the obtuse. If I had, let's see, I start with an obtuse angle here. There's my first obtuse angle. If I make the next angle also obtuse, well, I have three sides. There's no way I can connect those. There's no way this will ever be a triangle, ever. So, triangles are nearly always made up of acute angles. They just need one angle that's 90 degrees to be considered a right triangle, and they just need one angle more than 90 degrees to be considered obtuse. Every other angle will be acute because of the way they are. So, all right, now we know a few things about some types of triangles. And let's now use those rules, use the things that we know now to solve some problems. So, here is what we're going to do. First of all, does anybody still need to see this, or can I move it? Okay, I'll move it. Let's actually, I'm going to start a new page. Have kind of all the info on one page and then the problems on the next. So that's page one. And we'll go to page two. is still day 6. No. So let's start by drawing a right angle. Doesn't have to be exact. Use the side of my page to line this up. Make a second line here. And anytime we have a right angle, always mark the square, the box inside, so we know it's 90 degrees. Connect these two lines, so now I have a triangle. With this triangle, I'm also going to draw up against the side here, this line. I'm going to continue it a little bit past our triangle so that we have an exterior angle here too. And just leave it like that. Okay. This angle is 62 degrees. And I want you see if we can solve for, this will be angle A, this will be angle B. So, yes,
It's got
it would
the
be.
arches on it.
It absolutely would be. Yes. So Joseph just said, would B not be 90 degrees? What do you think? It would be 90 degrees. Why would angle B be 90 degrees? Because it is right next to this right angle here, okay? Whenever I have an exterior angle like this, and it's right next to an interior angle, I know that those two will add up to 180 degrees. Since this is 90 degrees, write that in, I know that 90 plus 90 is 180. If we wanted to write this out as an equation, here's how we could do it. I know that 90 plus B equals 180. They also form a straight line. Anytime you have angles that form a straight line, you have 180 degrees. So how would I do to solve this? Subtract your 90. Good. From both sides. And we would get B equals 180 minus 90 is 90. So angle B is 90 degrees. Now we want to think about how could we solve for angle A. If you think you have an idea, raise your hand and tell me, how do you think we could start solving A, Shayna?
Do I have, okay. Did I say the whole thing or?
Go ahead.
Okay.
It's a right angle, so you just take 90 plus 62, get that answer, and then subtract that from 180.
Yes, yes. We know that all three angles, because it's a triangle, will add up to 180 degrees. So if I have 180 degrees total, I already know this is 62, I already know this is 90. If we take those away from 180, what's left is going to be the measure of angle A. So let's set this up as an equation. I know that angle A plus 90 plus 62 all together makes 180 degrees. So A plus 90 plus 62 equals 180. You said we're gonna add 90 and 62 together, right? So let's do that. What is 90 plus 62?
152.
152. Okay, so now we have A plus 152 equals 180.
Now you subtract it from both
Yes,
sides.
and now we just subtract 152 from both sides. I don't know why I wrote that. And those cancel, and we get A equals what? 128, is that what you said?
Just
28.
Just 28. Ah, 28. So, angle A is 28 degrees. Not too bad, huh? Pretty much always going to be setting it equal to 180. Triangles, 180 is that magic number. We use it for almost every problem. Awesome, awesome, awesome. Yes.
So you say pretty much always.
I know, that's the same thing.
Pretty much always. So here's an example where we wouldn't use 180. Let me show ya. Let's see. And I'm gonna give you guys a worksheet here in a minute. I gotta make copies of it. We'll do it after we take a break. This is where it gets like more complicated with stuff like this. Yes.
I gotta leave at 1:15 because I have an eye doctor.
Okay, that's all right. No big deal. Okay, so let's see. One where you wouldn't set it equal to 180. Oh, B for using 180. I guess one where you wouldn't set it equal to 180 is if you have like angles that are equal to each other. So let me give you an example of that. Let's say I have, let's make an acute triangle. So I'm going to make 3 acute angles, kind of like this. I usually start with an acute angle that faces down, and then I just connect the two ends. And then we have a triangle. And you know what? I'm going to actually do this so that we have some exterior angles. All right, so let's say this is 60 degrees. We'll say this is 62 degree. And we'll say this is 2x right here. This would be like a two-step process. We would start by using 180, but when we get to the second step, we won't, and I'll explain that. So, first of all, if I wanted to solve for x, do I have enough information to do that right off the bat?
Yeah.
I do? We almost do. We don't yet, though. We actually don't yet because we've solved for something first. What would I need to find first?
The last.
My third angle here. I don't know what this angle is. Yes, Erica.
Put 60 and 62 together.
Put 60 and 62 together. Yes. And that gives us 122. Yes. Now here, let me write out the equation that's happening. I'm going to call this, I don't know, M. Now, these three angles, what do they add up to? In a triangle? 180, always. That won't ever change. That'll always be the same. But we said we were going to start by putting together 60 and 62, and that gives us 122. Bring everything down. Now, Erica, yes, what would I do next?
180 minus 122 will give us M. Then divide by 2 will give us X.
Ah, yes, yes. So we're subtracting 122 from 180, and what does that give us? 78? Okay, so 78 is the measure of our missing angle M. Is 50? 58? Did I miss here? Sorry guys, I'm just like going with what I hear. Let me type it in. I'll quit being lazy. 180 minus 122.
58.
Yeah, 58. Sorry. Wrong. 58. Thank you for correcting me. Okay, so I know now that this is 58 degrees. Here's where I wouldn't use 180. If I needed to solve for x now, I'm not going to do 2x plus 58 is 180, because how are these angles related to each other? They're vertical, they're right across from each other, so they are equal to each other. Anytime you have angles right across from each other, they're vertical and they're equal. So to solve for x, we would say 2x is equal to that angle across from it, 58. If you're solving for a missing interior angle, angles inside the triangle, you will always use 180 every time. When you have something that's a little different, like we start looking at exterior angles and comparing ones that are equal, that's when we don't use 180. Does that make sense?
Yeah.
Perfect. Okay, and then Erica, you said earlier we would divide by 2. And what would our answer for x be?
49.
X equals 29. Perfect. Okay. So, there's our little example. There's 2 examples actually, and I think sometimes the best way to understand how to use what we just learned is by just doing a whole bunch of practice, and that's where this worksheet is going to come in. So I forgot to make you copies. Do that before we can do this. So how about we take our break now? So I can make the copies and you're not waiting on me in here doing nothing. And let's say take 15, and we'll be back about 10:28, 10:30-ish, 10:30-ish. Let's go with 10:30-ish. Okay, so be back at 10:30 at the latest. And I'll have some copies ready for you. We'll go over some examples.
I'm done with this. I'm turning it on.
All right, guys, we are back, and all of you should have a copy of this worksheet at your table. If you do not, there's extras up at the front of the room. I think I got everybody though. And I'm just gonna write on the top that this is day 6. So that I can keep track of when we did it. And it's noon. So we just took a few notes talking about the sum of interior angles in a triangle. And this worksheet has, I believe, 20 questions involving interior angles. And every time we use interior angles, those 3 angles always add up to 180 degrees. So let's look at number 1. See how we can go about solving for x. So I have these 3 angles. I've got a 71-degree angle. I've got a 55-degree angle. And then I've got an angle that I don't know. Okay. So if I wanted to set up an equation to solve, I'm going to show you how to do it for number 1. And as we move on to the rest, I'm going to start having you guys jump in and explain it to me and the rest of the class as well. So if I have these 3 angles, I know that all 3, when I add them together, I will get 180 degrees. So what I'm going to do is just start writing all 3 in order with plus signs in between them. So I have 55 plus 71 plus 8x plus 6 and all of that is equal to a total of 180. So just like whenever we had angles that we were solving for x, now we're just doing 3 angles instead of 2. We've got a triangle. The very first step we always take is we see, are there any like terms that can be combined? So do we have any like terms we can combine?
Yeah.
Yes, we do. We have 55 and 71 and 6. All 3 of those are plain old numbers that don't have variables attached. And they're all positive. So we're just going to add those 3 together. So let's see. 55 plus 71 plus 6. And I get 132. So I'm going to cross all that out so I know that I'm done with it. And I'm going to write 132. All that I have left on this side of the equal sign is my 8x. So I'm going to bring that down. 8x plus 132. Good. Equals, we'll bring down 180. And now we have a very normal looking equation again. Raise your hand if you know how I would go about solving this the rest of the way. Holly.
Subtract 132 from 180.
Perfect. Subtract 132 from 180. That'll cancel. And let's see, what is 180 minus 132? 48. bring down my equal sign. I only have 8x left, so I'll bring that down as well. 8x equals 48. What will my last step be?
Divide.
Divide. Divide by 8. Both sides. And I will get x equals what? 6. Good. X equals 6. Perfect. Now, bless you. Yes, Erica.
I got the same answer, but I think I did a little bit different.
How did you do it?
I did 71 plus 55 gives me 126. Then I did 180 minus 126 gives me 54. And then 54 minus 6 equals 48. Divided by 8 equals 6.
Okay, that is another way to do this, and I actually love that method because sometimes it makes more sense to people. I'm gonna go deeper on that. Yes, Shayna.
I was gonna say, is it the same thing? You can plug your numbers in to make sure that you got everything right.
Yes, yes. And just like Shayna said as well, you can take that 6 that you got for x, plug it back into 8x plus 6, and make sure that those 3 angles do add up to 180. And if so, then you got it right. Now I want to talk a little bit about what Erica said her method was, because it is also a great way to solve it. So it sounds like what you did is instead of adding them all together, setting it all equal to 180, sounds like you solved for this missing angle first, right? Okay, so here's another way to do this. Instead of making this big equation, you could also do it this way. You could say, well, I know that all 3 angles add up to 180. So let's actually just solve for this angle measure first. Let's not solve for x. Here's how we would do that. I know 55 plus 71 plus, well, my missing angle, I'll use a little m for missing angle, equal to 180. And then you said you added these together and subtracted from 180, right?
Yep.
Perfect. So let's do that. 55 plus 71, what did you say you got?
126.
126. And still plus m equals 180. And then what did you do next?
100 minus 126.
Good. Minus 126. Okay. So that would leave us with our missing angle equaling what? 54. Okay, so now that we know that this missing angle is 54 degrees, I'm guessing what was the next step you took? You said 54
Minus
equals to 8x plus 6? Okay, yeah. So what we could do next is take 8x plus 6 and we know that since this angle is 54 degrees, then it must be equal to 54. And then you could solve it from there and you'll get the same answer. You said you subtracted 6 from 54, and that gave us the 48. Perfect. And then we end up right where we were earlier. 48 equals 8x. And look at that. It's the same thing. 8x equals 48. Divide by 8, and you'll still get x equals 6. So there are so many different ways to solve. Usually I'm showing you the most basic way to do it. This is another excellent way to do it. Now, if keeping track of all these different numbers seems a bit more difficult, sometimes it's best to just go with the basic way that I'm showing you. But this is, honestly, this might make a little more sense to some of you. I think it makes a whole lot of sense to me to do it this way, because then I'm not dealing with all the other numbers at the same time. Yes.
Is it okay if I show you how I wrote it?
Yes, yes, let me see. And you're welcome to show everybody if you want, because it might be helpful to someone. So this is how Erica did it. And do you want to explain your method a little bit? Because I think you would do a better job than I would.
So we've got 91 and 25, and we add those together, we get 126. You know, all of this is 108. So 108 minus 26 gives us just what's left. That's equal to 54. Then 54 minus 6 gives us 44. Then 48 divided by 8 gives us 6.
Perfect. Perfect. And that's an excellent way to do it. I love it. Thank you for showing us. That's awesome. So as you can see, the way I show you doesn't necessarily have to be the way you do it. You can do it in a way that makes more sense to you. And that's a great way. So there's number one, x equals 6. Do you have any questions about either of those methods before we try another? Let's look at number 2 then. So for number 2, I have an angle that is x plus 31. I have an angle that is 65 degrees, and then what's this angle? 90. If it helps to write 90, do it. I know that anytime you see that red box, it is 90. So, raise your hand if you want to tell me how to solve for x for this one, Amanda.
Does it matter what order we put it in though?
No,
Okay.
it does not matter.
It's gonna be x plus 31
Okay, x plus 31
plus 65
plus 65
plus 90
good plus 90
180.
equals 180. Good. So we just put all three of those angles, added them together, set them equal to 180. Okay. And Amanda, you can continue this if you like. What would you do next
We're
here?
gonna combine all of our like terms.
Yeah.
So we're gonna add 31 and 65 and 90.
Mm-hmm.
That's gonna give us 186.
186 is what we get when we add them all together.
So then it's gonna be x plus 186 equals 180.
X plus 186 equals 180.
Okay, and then we're gonna subtract 186 from both sides.
Okay, subtract 186 from both sides.
That's gonna cancel out
Perfect.
1, and then that's gonna leave me with x equals -6.
Yes, x equals -6. Now, I think a lot of times we get a negative number and we think we must have done something wrong. Remember, we are not going to have a negative angle, but you can have a negative x value. Absolutely can. How could I double check this answer?
Plug it in to the x value.
Plug it into my x value. So x plus 31, I could do -6 plus 31. What will that give us? 25? Yeah, 25. And we can make for sure that we know it's correct by taking 25 plus 65 plus 90, the three angles now. Do those three angles add up to 180 degrees? Let's see. They do, don't they? So if I wanted to do it by hand, well, 5 plus 0 plus 5 is 10. Carry my 1. 6 plus 9 is 15, 16, 17, 18. That, 180. Correct. Perfect. Okay, so there's number 2. What? Yes, we got -6 for x. Do we have questions about that? Yes, you are. Okay. I think that's a problem that a lot of us in here have. We second guess ourselves, don't we? You guys are a lot smarter than you think. You're very intelligent people. You're getting this stuff correct. It's never a bad idea to, take a second look and make sure it's right. But you guys are very intelligent. Hi, Lisa. Awesome. Okay, so we're gonna scoot the paper up and let's look at number 3. We'll do this one together. And then I'm gonna let you do some on your own. Okay, so I have 3 angles in my triangle. 48 degrees, 91 degrees, and 5x plus 1 degrees. I want to solve for x. Who can raise their hand and tell me how to start the problem? Rhonda.
Okay. 5x plus 48.
Almost. You're jumping ahead a little bit.
Okay.
What's after 5x?
So my answer's gonna be wrong.
That's
Because
okay.
I didn't see the 1.
That's okay.
I
It'll
don't
only
know
be
how
off
to
by
hit
1.
that.
It'll only be off by 1. Continue from there though. I've got 5x plus 1 and then what?
Plus 48
Plus 48.
plus 91
Perfect. Plus 91
equals 180.
equals 180. Perfect.
And then you you combine the like terms.
Yes.
48 plus 91 plus the 1.
Yes, plus the 1. So we're gonna add all 3 of these together.
And then
So-
bring down your, cancel those, and then bring down your 5x.
Okay, so let me see what number that gives us. 1
Oh,
plus
okay.
48. You're okay. Plus 91. And that gives us 140. And let's bring everything down, right?
Yes.
Okay, so 5x plus 140 equals 180.
And then you, subtract 140 on both sides.
Perfect. We'll subtract 140 from both sides.
So 140.
Perfect. Cancel the 140s.
Bring down the 5x.
Bring down the 5x.
5x, what did my x today? Equals 40.
Yes, 180 minus 140, that gives us 40.
And then divide by 5 on each side.
5 by 5.
X equals, cancel.
Perfect.
X equals 8.
X equals 8.
If I can.
Good.
Good job.
Very good. Okay. So there's our third example. I'm going to set a timer now. I'm going to give you guys a good 15, 20 minutes. And I want you to finish as many of the problems on this worksheet as you can in that time. And I'll be around to kind of look at your work, see how we're doing. Feel free to help each other out. Especially if anybody came in a little late, they might be a little behind. So if you are somebody, especially like if you just get it right away, and you might be somebody thinking, man, this is boring. I already know how to do this. Okay, guess what? It doesn't have to be boring because you can switch from being done, getting it, to kind of being another teacher in the room. You can help your classmates, okay? If you know something well, you should teach it to others, okay? Be a helper. So I'm going to pause our recording and I'm going to set a timer for us to see how we do. Okay, so number 1 we did together and we got x equals 6. If any of these you don't have correct on your paper, feel free to circle that, and at the end we can talk about them. Number 2, we got -6 together. Number 3, we did together as well. We got x equals 8. And number 4, x equals negative 11. Okay, next page. Number 5, we have x equals negative 5. Number 6, x equals 4. Number 7, x equals negative 12. And even if you aren't to this point or any future ones, it's not a bad idea to go ahead and write the answers down just so you have them to look at later if you want to do more practice. Number 8, x equals 10. Number 9, x equals 2. Number 10, x equals 5. Okay, before I go to the next page, make sure everybody has this written down.
Equals 5.
5 for number 10, yes. Anything that doesn't match anyone's paper, circle that one. We can talk about it after I give you all the answer. Okay, let's go ahead to the next page, page 3. Number 11. See, x is negative 6. Number 12, x equals negative 12. Number 13, x equals negative 10. Number 14, x equals negative 4. Quite a few negative numbers. Page 3. And to the last page, which is page 4. Number 15, x equals negative 4. Number 16, x equals 12. Number 17, x equals 11. Number 18, x equals 11 again. Number 19, yes, x equals negative 12. And number 20, I'm not going to tell you, don't tell me. This is your exit ticket. This is your exit ticket. Don't tell anybody. Don't tell anybody. Okay, this is your exit ticket. I gave you a copy on a separate piece of paper. Looks like this. Okay. I have these answers up here if anybody missed any. So real quick before I answer questions, the rest of the time today we still have a good 40 minutes. If you feel confident, if you've got your exit ticket done and turned in, you are free to go. If you would like to stay and talk about any of the numbers that you're not sure about, feel free to stay when we get kind of settled back in and everyone who's staying is here, everyone who's leaving is gone. We'll go through some of these together if anyone wants. So pause that.